All right, so today we're in section 7.4, comparing linear and nonlinear functions. All right, so it pretty much is what it sounds like. Linear is a straight line, and nonlinear would be not a straight line. It could be curved, or it could just kind of peak and then go in the other direction, but it won't be a continuous straight line. So what is the difference between a linear function and a nonlinear function? Well, with linear, there's a constant rate of change, which we call the slope. That's why in this chapter, we could use the framework of y equals mx plus b, because m stands for the slope. So you're going to hear me talk about that a lot, okay? And really, each of these examples, can it be written in slope-intercept? Is there a rate of change? Is there an m value? All right, so nonlinear function, you're not going to find that pattern, okay? There won't be a pattern. There won't be that rate of change. There is no slope. So that's what we're looking for. That's our basis. Let's look at example 1. All right, in example 1, I'm looking, if you remember back in section 7.1, so this is Monday, okay? We said as x increases by 1, y decreases by 4. Do you guys remember that problem? So that's what we're looking for here. We're looking, okay, do my x values and y values, they don't have to increase by the same number top and bottom, but is there a constant rate? So how do I get from 3 to 6? Add 3. Okay, how do I get from 6 to 9? Guys, tell me. Add 3. Okay, so I'm starting to see a pattern, which the pattern tells me constant rate. How do I get from 9 to 12? Add 3. So now let's look at the bottom. Look at your y values. All right, so don't say anything out loud yet. All right, how do you get from 40 to 32? Go ahead and write what you think goes there. All right, so how do you get from 40 to 32? Subtract 8. How do you get from 32 to 24? Subtract 8. What about 24 to 16? So because there is a constant rate of change on x and y, you're going to say what is happening, just like we did in 7.1. As x increases by 3, y does what? Decreases by 8. So the function is linear. It's linear because there is that constant rate of change. Let's look at the second table and try to find our pattern. How would I get from 1 to 3, guys? Add 2. What about 3 to 5? What about 5 to 7? So right now it's looking constant. Now let's go down to my y's. How do I get from 2 to 11? How do I get from 11 to 33? You're still adding. Technically, yes, I guess. You're adding. Well, we're still just adding, okay? Either way, though, is it a constant rate of change? No. So all you have to say on this is it's not linear because there's no constant rate of change. All right? There wasn't that consistent pattern between x and y like we had on the first one. So you have one problem like this on your homework tonight. You need to copy down the table and fill it in like this. This is your work. And then you would answer yes or no, okay, just like we just did. Okay, so this example probably is the most important example of the lesson. All right, determining whether an equation is linear or nonlinear. So now I don't have a table. I'm not necessarily looking for a pattern. Here's my go-to. Here's my basis. Can the equation be written in y equals mx plus b form? Notice I didn't say, is it written? Can it be written? So some of these equations, which we've already done, we could rewrite them. We could rearrange them. All right? Maybe just I need to move a couple terms around. And then it could be written in slope-intercept. So let's look at this bottom left one first. Y equals x plus 5. Going by the order of the terms, does it match up with slope-intercept form? How does it not?
Yes.
Absolutely it does. There's no m value because 1 is understood. But this is already, there's no rewriting that I need to do. This equation is in slope-intercept. So I don't have to do any work at all. All I have to do is say linear. Linear. Okay? It's already in slope-intercept. Already.
Oh, we need to write that?
Yep. Slope-intercept. It's going to say explain on this section. Okay? So if it's already slope-intercept, that's easy. That's the easiest one we're going to do out of the 4. All right? That's why I did that one first. All right, now let's go up. Let's go up to the next one up. Y equals 4 times x minus 1. As it is written right now, is it in slope-intercept? No, it's not, because I can't have distributive property. However, could I do that distributive property? And regardless, okay, so even right now, let's just pretend I don't know what's going to happen, okay? But I do know that I need to do this distributive property to see if I could get it in slope-intercept. So let's do the distributive. Whether it is or isn't, you have to distribute. Y equals, what's 4 times x?
4x.
What's 4 times negative 1?
Negative 4.
Negative 4. So now I need to evaluate again. Is there anything else I could or need to do, or what is this in slope-intercept now?
Yeah.
Okay, so after I distributed, I evaluate. Do I have y by itself? Mx and b. So this is my work. This is my proof. It's linear. It's linear. You have rewritten now in slope-intercept form, and it's a linear function. Okay, so I look over here in the second column, I say, well, that x cannot be connected to a fraction like that, okay? So again, you might be looking at it and think, well, like maybe, possibly, well, you know it can't be in the fraction. The only thing you could try to do is multiply by x over 1 to cancel. So you could kind of experiment. Well, if you multiply one side by x, what do you do to the other side? Multiply it by x. Now you have xy equals 4. Well, you need y by itself. So the 4 is by itself, which is what you needed. But how do you get y by itself? What are you going to have to do? Divide by x, which can't happen. So you're right back where you started. Okay? This is not possible. This is non-linear because you can't rewrite this in slope-intercept. It's non-linear. And just a little bit of work of you trying to get it in slope-intercept and realizing I'm right back where I started, that's all you need. Okay? It's non-linear. All right? So let's look at the next one. Okay? Remember the format. You guys ready to look at the next one? Y'all kind of remember the format. Okay? So I know that x needs to come first, so y equals negative x squared plus 1. Do you see what I did there? All I did was just reverse the order. Okay? This would be all fine and dandy, except one problem. Yes, the exponent. I can't have x squared, but if I try to take the square root of this, then I have to take the square root of everything, which also can't happen. So even trying to do this is non-linear. Because I can't take the square root. Okay, the square root. Because of the square root. All right, that's what's blocking it from getting in slope-intercept. So as long as you can't, guys, your explanations in this section are going to be different. But you just need to tell me which part of the equation is keeping it, all right, from getting into slope-intercept form. All right, that's going to be nonlinear. All right, how did you do on that? You're probably going to need some practice, okay, which is another reason why we kind of have a little bit of a shorter lesson today to give us time to do some practice together. All right, but any questions so far? You more or less kind of getting what we're doing here? Can we get it in slope-intercept form? Sometimes yes, sometimes no. The whole goal is to get y by itself. All right, now example 3 is literally just a matter of looking at the graph. Is it a continuous straight line? Number 1? Nope. So you say nonlinear. Okay. Number 2? Yes. It is linear. You say, well, it's horizontal, so it's still a continuous straight line. What about number 3?
Yes. It's just a straight line.
It's not continuous, though. It breaks.
Oh.
So it's nonlinear because it breaks. All right. It's almost like it snaps in half and then it... All right. It's like a little mountain. And then what about the 4th one? That one's familiar.
Yes.
Okay? Yes. All right, so we're going to stop here real quick on this one because number 1 on your homework looks pretty similar to that. What if I asked you, okay, well, I should have said yes. I should have said linear. I'm sorry. I should have said linear on that one. So because it's linear, that means I can write an equation. That means I can write an equation represented by this graph. There are no points on the actual line. This is exactly like number 1 on your homework. Okay? So, if it's linear, I can write an equation. Here's what you're going to do. Even though there are no points drawn on the graph, you can start at any point where the line crosses the x and y evenly. Okay? Please pay attention to this. Okay, so it crosses here, it crosses here, it crosses here. Do you see what I'm doing here? All right, you can establish a point. Remember, the line is made up of millions of these points. So all I'm doing is establishing the point where the line completely intersects x and y. Do you see that? It's right on the grid line. And then just count rise over run. Rise over run. It does not matter which 2 points you do. What is the slope? Y equals, what was it? Rise how many?
1.
And run 1. So 1x. And where does it cross the y-axis?
0.
Plus 0, or you could just say y equals 1x. Okay? So that's going to be number 1 on your homework, is to write the equation from the graph. What's going to throw you off is that on the homework, it doesn't have actual points on the line. But remember, the line is made up of points. So all you have to do is just draw the point on the part where x and y cross perfectly. All right? And then on the next one, and then you can count your rise and your run. All right, that's... Oh, wait, we need to do one more example. We're just looking for the pattern again. All right? I forgot. It's the wavelengths, the light waves. All we're doing on this one is the modeling real life. The frequency in terahertz of a light wave is a function. Okay, so there's my hint. It's a function of the wavelength, x, in nanometers. Is the function linear or nonlinear? Does anybody remember, based on when I'm looking at this kind of information, what am I looking for it to be linear or nonlinear? The patterns, okay? So I want you to take maybe just about 2 or 3 minutes, see if you can establish the patterns, all right? So how are these values changing? Is the pattern consistent? All right, might need to break out this calculator, that's okay. You could do some mental math here, though, too. Absolutely, you could. All right, so I'm going along x, and I see every x value, what am I doing? Minusing 65, okay? So far, it's looking linear. I'm minusing 65. I come down here to my y's, and it looks like I'm minusing 50. I'm sorry, plusing 50, plus 50. All right, but if I'm adding 50 again, it should have been 54.
Yeah.
554, but it was 566, so I added 62. So this is the place that breaks the pattern, okay? So I'm going to say nonlinear, no constant rate for y. There was a constant rate for x, but there was no constant rate for y, and you showed me that by at least going to the point in the table where the pattern broke. All right, is that straightforward enough? Okay, so the explain is this, guys. You have to have an explanation on these 3 problems on your homework. All right, and that's everything you need to know for 7.4 and Chapter 7 as a whole.